Okay, this is lesson 7.5, proportions and similar triangles. Again, try to have your book open so you're looking at this as I'm going through it. Sometimes it might be difficult to see up here what I'm actually looking at and reading. So make sure that you're looking in your book as well. So that way if something is hard to read, it's there in your book. This is just a snapshot of your book. So let's start with this. Proportionality. We already talked about proportionality. When we say that P lies on GH and a point Q lies on JK. If GP is proportionate to PH and JQ is proportionate to QK, then we say that GH and JK are divided proportionally. Okay, so basically what it's saying is that even though the length of this segment is shorter than the total length of this segment, they're still broke up into proportionate parts. Okay? Triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay, so here's where this comes in. It says in triangle QRS, if TU is parallel to QS, then RT has to be proportionate to TQ as RU is proportionate to US. So basically, it says that this proportion and this proportion, or excuse me, those two sides are proportionate to these two sides. Okay, so that's how that works, I guess. So according to this, 4 compares to 8 as x compares to 12. So we've got this small side compares to this side as this small side compares to this side. And so that should work. So we cross multiply, we've got 8x is equal to 4 times 12, which is 48, equals 8x. So x is equal to 6. So using this triangle proportionality, we are able to set up a proportion and solve it. Okay, here again, this time is kind of a trick, so you got to be careful because you've got the small side, 3, compares to this smaller side, which is 9, as y compares to this smaller side is not 20. It's 20 minus y because it's the full length minus the small part. And so when we cross multiply, we have 3 times 20 minus y equals 9y. And so now we can go ahead and solve that. We get 60 minus 3y equals 9y. Add 3y over, I get 60 equals 12y. So y is equal to 5. So this is 5. Converse basically says if these are proportionate, then the lines are parallel. So it says determine if the lines are parallel. Okay, well, they're parallel if 56 compares to 21, so this length compares to this length, is the same as this length, 48, compares to 16. Well, how do I know if they do? Again, I can use a decimal. I can go ahead and see what happens. 48 divided by 16 is 3. Oops. Let's do this. 48 divided by 16 is 3. 56 divided by 21 is not 3. It's 2 point something. I'm going to guess somewhere right around 2.7 maybe. So we know they are not equal, so we know that these lines are not parallel. They are not parallel to each other because the sides are not proportionate. Okay, go ahead and try these, and then I will go over them. First one is just finding the value of that x, setting up a proportion. The second one is determining if those two lines are parallel. Okay, welcome back. Let's go ahead and check this out. We know that x would have to compare to 4 as 10 compares to 5. So that's 5x equals 40, or x is equal to 8. This one, be tricky here. This side right here is 14 minus y. So we know that y compares to 14 minus y as 15 compares to 6. So you got to be careful there. So I know that if I go ahead and do the work here, 6y is equal to 14 times 15 is 210. 210 minus 15y. Because what I did was I took 15 times 14 minus y. Add this over, I get 21y equals 210. So y is equal to 10. Okay, so that's how that one worked. Okay, I'm going to erase that so I can do the bottoms here. Now, the next one, let's see if these are parallel. If they are, then I know 15 over 21 has to equal 17 over 23. So if I take 15 times 23, I get 345. And then I take 17 times 21, I get 357. So these are not parallel because those two numbers are not the same. Okay, let's set this one up. 4 over 8, is that equal to 6 over 12? And that of course is, because they're both 0.5. So they are parallel. QR is parallel to ST. All right, the last concept we're going to talk about is called the midsegment of a triangle. The midsegment of a triangle is when you have a segment that goes across the middle that goes through the midpoints of each side. Goes through the midpoints. If they go through the midpoints, if these two are midpoints, you notice that they are because you've got congruent segments there and congruent segments there. If they go through the midpoints, then this DE is parallel to the last or the bottom side, and it's half the length of the bottom side. Okay, so I know these two are midpoints, and since QS is a midsegment, it equals half of PT. So it's half a 10, which is 5. So this is 5. All right, find the value. We know these two are midpoints, so P is 8. What's Q? Q is going to be twice as long as the midsegment. So Q is 28. It says here, use the midsegment theorem to find the perimeter. The perimeter is the distance around. Well, I know this one has to be 10, so the distance around is this side plus this side plus this side. So it's 6 plus 8 plus 10, which is 24. The perimeter is 24 because you add this side, which is 6, this side 8, and this side is 10. And that's it for section 7.5.